Hello, Algebra 2. Here is your 3.123 review. So we're going to start off with factoring, and whenever we're doing factoring, I always start off with the little diamond. Remember, what goes on top is A times C, and what goes on the bottom is your B. So A is 1, and C is a negative 28, so that product is a negative 28. A negative 3 goes down here. And you want to ask yourself, what times what will give me a negative 28, but add up to a negative 3? So we need the larger number to be negative. So a negative 7 times 4 is a negative 28, but negative 7 plus 4 adds up to a negative 3. Because there's a 1, and only when there's a 1 as your lead coefficient, can these numbers that you come up with go directly into your parentheses. So this will be x minus 7 times x plus 4. And then we set each factor equal to 0. So x minus 7 equals 0, x plus 4 equals 0, and we get two answers, always two answers. So x equals a positive 7 or x equals a negative 4. All right, and that would be that solution. Now sometimes it gets a little bit harder. So we have in this next problem, on top in our diamond is going to be 4 times 27, which is 108. And on the bottom we have 21. And so off the top of my head, I don't know what would work. So I start with the 108. I know that it's 4 times 27 because that's how we got it, A times C. That won't add to a 21, so I start to break things down. 27 is also 3 times 9, and I play around with different combinations of the factors. And I notice here that I have 12 and 9, and I know that 12 and 9 would give me 21, so that's what goes in the side. So we know that 12 plus 9 equals 21. So what we're going to do is called factor by grouping, but first we need to make 4 terms. So we rewrite 21 using those 2 terms. So 4x squared plus 12x plus 9x plus 27. And factor by, so now I have 4 terms. When you have 4 terms, you can use your factor by grouping. So I'm going to group those 2 and then group these 2. So what's common to 4x squared and 12x is 4x. I can pull that out. I still have an x plus 3. And on the other side, what's common to 9x and 27 is 9. Notice I also have x plus 3. 100% of the time, these two should be the same factor. So now I can pull that factor out, and what's left behind gets put into its own parenthesis. And now we set it equal to 0 and set each factor equal to 0. So this will give me x equals negative 3, and 4x plus 9 is going to give me x equals negative 9 fourths. You'll always end up with a fraction on these ones where a is not 1. All right, let's try that again. So over here, we do our diamond. So 5 times a negative 6 is a negative 30. The sign is really important. Don't forget your positives and negatives. This is 13. So 10 and 3 won't give me a negative 30 and a positive 13. So we need a different pair. So we're going to use 15 minus 2. That would give me a positive 13, but a product of a negative 30. So the idea is we're going to rewrite 13 in terms of 15 minus 2. So we have 5x squared plus 15x minus 2x minus 6. So we combine the first two and these last two. So what I get is a 5x I pull out. That leaves me with x plus 3. And in the second one, always, always, when you have a negative here, pull out a negative. So -2 is common, and it will always change this sign. So this becomes x plus 3. And if you need convincing, distribute that -2 back through. -2x minus 6. So we're not quite done. So then we can factor this with our common factor here out in front. And what is left outside goes into its own parenthesis. And now we set each factor equal to 0. So x plus 3 equals 0 gives you x equals -3. 5x minus 2 equals 0 gives you x equals positive 2/5. And that would be your two answers. Okay, so that is the factoring. Now what it wants you to do is determine whether you would use the square root method or factoring and kind of explain your reasoning. I'm going to explain it. I explained on the hard copy, but I'm going to just do it verbally this time. So the first one, I'm going to use the square root method. And the reason for that is because I only have this one squared term. So remember, the square root method says isolate your squared term. So we add 15 to both sides, divide by 2. So I have x squared equals 15 halves. Once I have my squared term isolated, I take the square root of both sides without forgetting my plus or minus. The problem here is you're not allowed to have a radical in the denominator here. So I'm going to, let's rewrite this, x equals the square root of 15 over the square root of 2, and multiply top and bottom by rad 2. So our final answer is x, oops, I lost my plus or minus, sorry. So I have x equals plus or minus rad 30 over a positive 2. And no radicals in the denominator. All right. This second one, since I have more than just one squared term, I am going to try factoring. So I do the little diamond. 3 times a -2 is a -6. My middle term's a -1. So that means I'll have a -3 and a positive 2. Now for those of you guys who like the double rainbow, I'm going to do it on this one because we know our first term has to be 3x. There's only one way that something times something can give me 3x squared. So then I do my little double rainbow here, and the numbers that are on the side go on the rainbow. So 3 goes into a -3, so -3 goes there and my 2 goes there. And you ask yourself, 3 times what is a -3? So that'll be a -1. This one is 1, so 1 times what is 2? That's a positive 2. So we set that equal to 0, and then set each term, each factor equal to 0. So this will give me x equals a -2/3, and x minus 1 equals 0 gives me x equals 1. And there are my two answers for that problem. All right, and then off to the side here, we already have our squared term isolated. So right off the bat, I'm going to take the square root of both sides, realize that plus or minus rad 8 can be simplified because 8 is 4 times 2. So this comes out as 2 rad 2. So I've taken the square root of both sides, so I have x plus 3 equals plus or minus 2 rad 2. And then we just have to isolate our x term. So x equals -3 plus or minus 2 rad 2. And that would be our answer. All right. Now, down below here, we have two complex numbers. Remember, it's a plus bi. You have a real part, and you have the imaginary. Together, they make up a complex number. So all you have to do is set the real part equal to the real. So we set 7x equal to 14. So x equals 2. and we set the imaginary part equal to the imaginary. So we have a negative 6i equals yi, and so obviously y has to be negative 6. And that's all you have to do with those. And now down below, adding and subtracting. So again, same idea, you can combine like terms. So we have 12 minus 6, and then we're going to have plus 4i plus 11i. So adding the real with the real, the imaginary with the imaginary, that gives me 6 plus 15i. And over here, the only thing you have to be careful is that negative, it's going to distribute to both terms. So I like to kind of rewrite it. So what we have here is 1 minus 13, those are our two real parts, and then I have 15i minus 5i. So that's going to give me a negative 12 plus 10i, and you always write the real part first. Okay, then these bottom two I have to get to before my cat wants to go out. So we're going to distribute. Remember that I squared is going to equal negative 1. So you always simplify. You never have I squared in your final answer. So we have your negative 11 times a negative 2. That's 22i minus 11i squared. So this I squared, because it's a negative 1, is going to change the sign to a plus. So I have 22i plus 11, but we don't write it like that. You always put the real part first. So this is 11 plus 22i. Okay, next one, we're going to FOIL, first, outer, inner, last. So the first term's negative 4. Then the outer terms, 2 times 5 is 10i. Then my inner is negative 14i, which I like to write underneath, like terms. And then we have our plus 35i squared. And so this I squared never appears in your final answer. It's going to make this a minus. So combining like terms, I have negative 4 minus 35. And then these two become 10 minus 14 is minus 4i. So your final answer, negative 39 minus 4i. Okay? And then on to the back page. Okay, we're on page 2, and notice these first 3 problems are solved by completing the square. So it's that process where you start off with isolating your x terms. So we're going to leave a plus blank, subtract 10 from both sides, and leave a plus blank. And remember, we always take half of that middle term and square it. So 3 squared is 9. It'll always be a positive number because you squared it, and you're always adding. And then we're ready to factor. So this will always be x, whatever's inside the parentheses here. So minus 3 squared equals negative 10 plus 9 is a negative 1. And at this point now you do the square root method. So we take the square root plus or minus the square root. So I have x minus 3 equals plus or minus I, and then I add 3 to the other side. I didn't need those parentheses there. So 3 plus or minus I, and that would be your final answer. There's nothing else you can do with that. So this next one, same process. So we have x squared plus 12x plus blank. We subtract 4 from both sides and leave plus blank. So we are going to add half of the 12 squared to both sides. So 6 squared is 36. And that will then factor into x plus 6, since that's 12 over 2, positive. So that's our perfect square, equals 36 minus 4, which is 32. Now we're ready to take the square root of both sides. And you want to simplify your rad 32, which remember is 16 times 2. That will become 4 rad 2. with the plus or minus. So we have x plus 6 equals plus or minus 4 rad 2, and we isolate x. So negative 6 plus or minus 4 rad 2. And that would be that answer. All right, this next one, it's like, what? It looks a little bit crazy. So you want to kind of put it in a form that is a little more familiar. So we're going to distribute, and we have 4x squared plus 24x equals negative 40. Now you cannot complete the square when you have a coefficient other than 1 in front of your squared term. So luckily, everything in this problem is divisible by 4. So we have x squared plus 6x plus blank equals negative 10 plus blank, and this is very similar to our first problem. So half of 6 squared is 9, which allows us to factor this into x plus 3 squared equals, once again, a negative 1. We do the square root method with the plus or minus. So we have x plus 3 equals plus or minus I, and then isolate x. So we have a negative 3 plus or minus I. And that would be your solution. Okay, these next 3 problems are really just to give you some practice with your systems of equations, because you should never get rusty in that. So on 15, notice I'm all ready to just go ahead and add these 2 equations together because my y's will automatically cancel. So that's a 4x equals 28. So right off the bat, we get x equals 7. We hold on to that. We have to plug it back in. I'm going to plug it in here. So 7 minus 2y equals 13. So negative 2y equals 6. Y will be a negative 3. And you write your final answer as an ordered pair. So 7 comma negative 3 is really what we want. All right. Now they aren't always so easy and set up how we would like. So in number 16, notice nothing cancels right away. So what I'm going to do is I'm going to multiply everything in that top equation by negative 2. So that gives me a negative 2x minus 6y equals a positive 24. And now I'm ready to just add these together. So x's go away. I get negative 4y equals 24. So y is a negative 6. And then we substitute it back in. I'm going to substitute it into the first equation. So x plus 3 times negative 6 is a negative 18 equals a negative 12. So x is going to equal negative 12 plus 18, which is going to give me 6. So my final answer is 6 comma negative 6 when we write it as an xy ordered pair. All right, over to 3 by 3s. Again, you do not want to forget how to do these. So we look at this, and I think, okay, what variable do I want to isolate? And I think on the paper copy, I did y's, but you know, now that I'm looking at it, I am going to eliminate z, because I see plus c minus c plus c. So if I add a and b, this is what I get. I get 2x, and as an added bonus, y goes away, z goes away, equals 6. So right off the bat, I know x equals 3. That was really friendly. So now I'm going to add b and c together. But remember, I already know that x is 3. So what I really have here, well, actually, I'll just go ahead and add them first. So when I add those, I get x minus 2x. So that's going to be negative x plus 3y. My z's go away, equals negative 15. But I can plug in my 3 here. So I have negative 3 plus 3y equals negative 15. So 3y, if I add 3 to both sides, is going to give me a negative 12. so y will equal -4. And then all I have to do is plug everything back in. I'm going to plug it all into a. So I have 3 minus a -4 plus z equals 13. So 7 plus z equals 13, and z therefore equals 6. And we write it as an ordered pair x, y, and z. And that's it. So that's a review of your systems of equations. And the last problem is one of those height problems that we talked about. So you have your gravitational constant, your initial velocity, and your initial height. This wants us to find the maximum height. So it's asking for the y-coordinate of your vertex. And the easiest way to find your vertex, remember, is to do the opposite of b over 2a, and whatever you get, you plug it back into your equation. So we have t is going to be the opposite of a positive 32 over 2 times -16. So that gives me -32 over -32, which is a positive 1. So h of 1, because we really want the y value, is -16 times 1 plus 32 times 1 plus 4. So that gets me 16 plus 4. So my maximum height is going to be 20 feet. All right, I hope that helped, and happy studying.